Okay, so let's look at question 6, which gave us a polynomial using z's. Okay, and the first question asks us to write down the sum and product of the roots. Okay, so this is pretty should be a pretty straightforward question. So the sum of the roots will be well, what would be the sum of the roots? Well, it's got to do with the first two coefficients. Hopefully we know that. So minus 1 over 1. Well, that'd be minus 1. Okay, so that's the sum of the roots. The product of the roots then would be using the last term, constant term here. So it'd be minus 1 to the power of how many we have, and it'll be the last term, 2, divided by the first term, 1. First coefficient, not first term. What's the power? Well, it depends on what the power is here. So it's power 5. So minus 1 to the power 5 is minus 1, of course, because that's an odd power. And minus 1 times 2 is just minus 2. So there's our sum and product of roots. Part B then asks for, what's that for? Show that. So show that z plus 1 is a factor. Okay, so if we use the factored theorem, if we sub in z equal to minus 1, if we get out 0, then it is a factor. Or you could divide it and also get a remainder of 0, so it'd be also a factor. So you can do that, but I think it's easier just to sub in minus 1, or you can so the polynomial with minus 1 in instead of z. Hopefully I get out an answer of 0, and therefore minus 1 to the 4, and therefore it would be a factor. So like that. Let's work out each bit. So that's going to be minus 1. Minus 1 to the power of 4 is going to be plus 1. Minus 1 to the power of 3 is going to be minus 1, but then it's going to be minus 1, which is also plus 1. 4 times minus 1 is minus 4 and plus 2. Okay, so well, they're gone. Oh, it doesn't work, does it? Have I skipped a term? Oh, I have skipped a term. Oops, forgot z squared. Z squared, oh, there's an ant. Great. Z squared, that's minus 1 squared. So minus 1 squared is going to be another plus 1 in here, which evens it all up. So it all does work out. Plus, that's 4, and then take away that 4. Okay, so it is 0. Okay, so I realized I made a mistake somewhere. Cool. All right. So it is a factor. I definitely knew I made a mistake because it was a show that question, and show that it would have to work. Part C then says the polynomial, so this polynomial that was given in the question, can be written in a different way. Of course it can, because we already know one of the factors, but let's see how it can be written. Z plus 1 is actually a repeated root, isn't it? Cubed z squared plus cz plus d. So it can be written like this. So yeah, so repeated root here. Okay, so they want you then to find what c and what d would be in this situation. So I think this is the bit that was causing you problems, but was it?
Yes, sir.
It was causing you problems, yeah? Okay.
Yeah, this one was. Even with Mr. Geary.
Oh, okay. Well, Any ideas, either of the other two of you? What d would be here?
Well, it would be the product, wouldn't it?
It would be the product. Explain.
The value of the product, because the sum is equal to C or Z, right?
The sum would be equal to C?
The
No.
Z to Z to Z.
2z.
Yeah.
No, the sum of the roots is -1. We figured that out above.
Yeah, wouldn't it just be the constant last term, so it'd have to be 2?
Yeah, so if we look at the original z cubed plus z squared plus 4z plus 2, 1 is going to have to multiply by d to get this 2. So what must d be? 1 times something. So it's the only way you can produce the constant term, because when we cube out this function, or this part of it, if we were to multiply it out, it's going to be all z's except for the last term, which is going to be 1. 1 times 1 times 1. And then everything here is going to be also impacted by z except for this thing times this thing. And therefore d has to be 2. Now you could work that out if you want. I think the mark scheme does work it out. It says, right, if I put in 0 into this function, if I put in 0 in here, what do I get out? I'll get out 2. So that means when I put in 0 into this function, I should also get out 2. And you can see that when I share the mark scheme with you. But you can just logic it out. The first times the last term will have to be the constant term. This last term times this last term will have to be the constant term. Okay, so that gives me d. So now I can change that, and I know d. But now I need to find c. Not quite as easy this time. Maybe not. But we've been given the original function. We know this. So we can literally find any point along that line. That point must match up with this. So for instance, if I sub in 1 into this, I'll get out a number. And if I subbed 1 into this, I should get out the same number, because they're the exact same thing. I have to get out the same answer. I have to get out the same range for my domain. So let's just sub in something easy into this and get an answer, the first one. So I'm going to do p with 1 subbed in and see what that gives me. I'm just going to work it out as I go. So that's going to be 1 plus 1, take away 1, plus another 1, so we're up to 3, plus 4, so we have 7, plus 2, so that's, no, we're at 6, sorry, so these two will cancel because they're both 1. So we're at 6 plus 2, which is 8. So if I subbed in 1 into this, I get 8. You can work that out longer if you want. Which means if I sub 1 into this, I also would get 8. So I get 8 equal to 1 plus 1 cubed times 1 squared plus c times 1 plus 2. And if I solve this out, I'm sure you can do this, you would get an answer that would work for c. So let's do it. 1 plus 1 is 2, and 2 cubed is 8. So already that's 8. It's 8. So that 1 squared is 1 plus c plus 2. Okay. Divide both sides by 8. We get 1 is equal to 1 plus c plus 2. So I divide both sides by 8. And rearranging of this, I think that's c plus 3 on this side. I could have done that here. C plus 3, take away 3, and we get c is equal to -2. And that's the answer for part C. Part D then is a hence, so you wouldn't be able to do this without having the other answer. So we needed C and we needed D. So these hence questions can be tricky very tricky if you don't get the part above. All right, so find the complex roots of pz equal to 0. So what's pz now? Well, they've already set that up for you. They have z plus 1 cubed, and now from the other part, I can fill in my c and d. Z squared plus, that's actually minus 2z from the c, and plus 2 from the d. Okay, so what do I know about this repeated root? Is it real or is it complex?
Real.
Yeah, it's real. It's going to be -1, isn't it? Repeated. Okay, so that's real. So that means this bit, if they're find the complex roots, this bit must be complex, or it must produce complex roots. And it's going to. How do we could test it to see if it. How do we test this to see if it would?
Discriminant.
Yeah, so I could use the discriminant b squared minus 4ac. So b squared is 2 squared, which is minus 2 squared, which is 4. Take away 4 times a times c. So that's going to be 8. So 4 take away 8 is negative. And that's going to be complex roots then, 2 complex roots, which is exactly what we wanted. So if I just solve this equation using my quadratic formula, which I will, so minus b, so that's minus 2 plus or minus the square root of b squared, which is minus 2 squared plus 4, sorry, b squared minus 4ac, minus 4ac, 1 times 2, so a, b, c, and all over 2 times a, so that's just 2. If I work all that out, you will get the complex root. So that's going to be 2 plus or minus the square root. We just worked this out, didn't we? Just make sure 4 take away, so it's going to be minus 4. Yep, all over 2. I need to convert that to a complex number. Here's our complex number. So if I want to take a sidebar over here, square root of minus 4 is going to be square root 4 times square root minus 1. Square root of 4 is 2. Square root minus 1 is I. So that is now 2 plus or minus 2i all over 2. Divide everything by 2, and we have 1 plus or minus I as my complex roots. So z is equal to. So there's our. So we know z has a repeated root at -1 and has a root at 1 plus I and 1 minus I. Complex roots. Okay, so that's question 6 done. Question 8 next. Okay, question 8. So it gives us a polynomial 2x to the 4 plus a 3x to the 3 plus a 2x to the 2 plus a 1x minus 12, and it is divisible by x plus 1, x minus 1, and x minus 2. Okay, so divisible by all those, and the question wants to find what's a3, a2, and a1, given that we know what divides in. All right, so one method I could go, and I haven't done this question yet, but one method I could go is sub in. If I substitute in minus 1, plus 1, and plus 2, I'm going to get 3 equations with 3 unknowns, which I can solve using my system of linear equations, which I can set up the matrix. Remember that thing? And I can solve that. I don't think that's the quickest way to do this. I think the quickest way is to, so my roots are -1, 1, and 2, and some other root, which I'm going to call p. Okay, so I got these 4 roots. And I'm going to use sum product of roots here. I'm actually going to use product of roots because we have 12 and 2. See the way? If I use product of roots, it's going to have A3, or sum of roots is going to have A3 in it. But if I use product of roots, I have 12 and 2, and I have all the roots. So that's only one unknown. Does that make sense? Hopefully it does. So if I product the roots, so multiply the roots, -1 times 2 times this new root, I've actually added another variable in. But you'll see what happens. Once I have the 4 roots, I'll be able to form this and then get a1, 2, 3. And I know that the product of the roots will be minus 1 to the power of, well, what's the value here? So it's the power of 4 all over minus 12, the last term, and the coefficient of the first term, 2. And I set up equation. There's only one unknown here, so I will get that final root. That's going to be minus 2p on this side. That's going to be a positive, so that's going to be minus 6. So what's p then? 3. Great. That's not the answer though, but that is my final root. So once I have all roots, I can just multiply it out. And so I have x plus 1, x minus 1, x minus 2. My last one I found out is x. Well, it's positive 3 here, so it's going to be minus 3 there. And that's my roots. Now, what you will notice here is, what do I need to multiply this by also? If I look at my
2.
I need to multiply it by 2, yeah, because if I multiply x times x times x times x, it will give me only x to the power of 4. It won't give me 2x to the power of 4, so it would have to be multiplied by 2. And that might be the final tricky bit. So I presume you can multiply that times that times that, and you get all your x squareds, x cubes. If you do it correctly, let's just do it. X squared minus 1, because that's the difference of 2 squareds. And that's going to be x squared minus 5x plus 6. And then combining x squared by all those. So 2 times x to the 4 minus 5x cubed plus 6x squared. Now multiply by the minus 1. Minus x squared plus 5x minus 6. All to be multiplied by 2. Let's just do a little check here. You see that 2 times minus 6 is going to give minus 12, which is what we wanted from the question, and 2 times x to the 4. So that's correct. So it's going to be 2x to the 4 minus 10x cubed. And let's just combine these two together as we go. So 6x squared, take away an x squared, is going to be 5x squared times 2 plus 10x squared as well. There's only this, so that's going to be another 10. Multiplying each term by 2 and minus 12. So what's my value of a1? a1 is this term. a1 equal 10, a2 equals 10, and a3 equals negative 10. Okay, one more question, and then I'll leave you guys do some study. Question 13, so the last question, I think it was an inverse, wasn't it? Yeah. Okay, so let's look at question 13. So we got a function here, and it's the square root of minus 2x. For minus 3 up to x and to 3. Okay. Find the inverse function of f stating and then state its domain and range. Okay. So inverse. Well, inverse, whatever way we do it, we have to let, at the moment, it's y equals the square root of 6 plus 2x over 6 minus 2x. So I don't know what way you do inverse, but we want to switch everything around. So I can start off by doing switching x and y, and then I don't know if that's or you can switch x and y at the end. So you just want to make x the subject of the function. So you completely switch everything around. You switch the letters at the start, which I did, which is fine. So how do I get rid of the square root? Square both sides. So I'm trying to get y equals again. So I've squared both sides. So that's great. Okay, so squared both sides. Multiply by both sides by 6 minus 2y. So that's going to be x squared times 6 minus 2y equals 6 plus 2y. Okay, so that's going to give me 6x squared. minus 2x squared y is equal to 6 plus 2y. All right, now we need to refocus. What do I need to get? I need to get y equals. So that means I group all y's on one side. Doesn't really matter which side. Well, because it's going to be positive y's, I'm going to group them on the right-hand side. So I get this is now going to add to this side. So I get 2x squared y plus 2y. And this is 6x squared, and this comes minus 6. Okay, hopefully we're happy with that. Now, how do I get y isolated here? There's two of them.
Factor it out.
Yeah, I got to factor that out. If I factor it out, I reduce it down to only one y term. So that's 2x squared plus 2. And that's 6x squared minus 6 still. So how do I get the y on its own? I divide this side by 2x squared plus 2. And divide this side by it. So I get 6x squared minus 6 all over 2x squared plus 2. And then I have y on its own, and it's now being inverse. So that's the inverse. So it's not, I would call it f inverse x. Oh, I can actually divide all this by a common factor to make it even tidier. So that's 3. If I divide everything by 2, I can make it tidier, but this is fine as well. X squared plus 1, just make it a little bit tidier. It'll help me with when I'm getting my domain and range. Okay, so up here, so I've done, that's the inverse. That's it done. But I need to do domain and range of this. Now up here, if we look at the domain of the original, it was very restricted. It only worked between minus 3 and 3 for this function. Only worked between minus 3 and 3 because why? Anybody? Why it wouldn't work outside minus 3 and 3? Blanca. Okay.
Maybe it's too complex.
Yeah, well, it'll give you a square root of a negative number. So let's say you just pick 5. That would give me 6 plus 10. So that's 16 on top. And on the bottom, it would be 6 minus 10, which is minus 4. So it'd be a negative fraction. Negative. It's not, well, it's going to be negative improper fraction. But it's negative. And the square root of a negative thing is complex. So it wouldn't be able to represent on your x-y axis, which this deals with x and y. So therefore, that restricts it. It only works between certain points. Now, so therefore, we must look at this. What restrictions would the domain have? Once we know the domain, we'll get, once we know the domain, there's a quick way of getting the range anyway. So what restrictions do we have? Anything? Is there anything we can do here? Is there anything we can fill in straight away? Can we fill in either the domain or the range?
There's no like square root, so it looks like domain can be whatever it wants.
Well, let's have a little look. Oh, not quite. So if we have the original function's domain and range, what can we say about the inverse function's domain and range?
The inverse of those.
Yeah. So the domain becomes the range, and the range becomes the domain, doesn't it? Or does it?
Yeah.
Well, if it's inverse, it should be almost the exact opposite. Okay, so we know our domain from the original one. That was from minus 3 up to 3. What was the range of the original one? So can I get anything less than 0?
No.
No, because the square root then would, in order for me to get that, it wouldn't make sense. the square root of the number would have to give a negative answer out, and that wouldn't work. So I can get any answer from 0 up to what?
All positive integers?
All positive integers? I can get decimals. I definitely get decimals, because like think about if I pick
I mean, all real numbers?
yeah, well, yeah, it can go all the way up to infinity. Yeah, because if x is a decimal, this top of the fraction could be really large, and this bottom of the fraction would be really small. But they'd both be positive, and that's fine. It'd be like, so like 2.99 or something, I think gives, does it? Yeah, 2.99 would give a really, really large number, actually, because that's going to be almost 12, and this is going to be almost 0. So you're dividing by almost 0 decimal, and then that will make it huge. So therefore, it can go up to infinity. So if I know the domain and range here, I just swap them. So the domain is going to be the opposite to, so you just swap the letters around, and you will get the domain and range, and that's it. That's it. So that's something you need to remember for inverse functions. The domain and range would be the swap as well. Okay, so domain would be x here, and the range would be y here. Or you can see the way they, in the mark scheme, they actually have it written like this, which is another way of writing the same thing. So that means from 0 up to infinity, which is another way of writing. I prefer this way because I think it's just a little bit clearer. But up to you. Okay, so that's the 3 questions that the guy wanted to go through, and that's great. You sent those through. The rest of the answers I'll just give you